Hello, I'm Jan Dolzer at Sutter Instrument. This is a tutorial about three components that make up the upper pulley assembly on a Sutter horizontal puller: the puller bars, the pull cables, and the pulleys. A defect in or poor adjustment of each of these three components can cause inconsistency and variability in your pull results. So Sutter Tech Support will point you to either this video or one of the three videos about the individual components. This tutorial applies to the Sutter P-97, P-1000 or P-2000 micropipette pullers, as well as certain discontinued models. Let's take a look at the upper pulley assembly on this P-1000 puller. The three components that we will talk about today are the puller bars with their V-groove bearings, the pull cables, and the pulleys.
The puller bars hold and position the glass capillary before the pull. More importantly, they control the movement of the capillary while the pull is executed. So it is crucial for appropriately shaped and reproducible pipettes that the puller bars are completely straight, parallel, and in a well-defined position. To achieve this, each puller bar is carried by three V-groove bearings. The puller bars must have some vertical play in the V-groove bearings. To test this, unlock the left and right puller bars from their spring stops. Now grab one of them at the narrow section and move it rapidly up and down. You should hear a clicking sound and clearly feel some play in the bearings. Since each puller bar is supported in the V-grooves of the bearings, its position is defined by the location of the two lower bearings and the amount of play in the upper bearing. This was adjusted in the factory and will not normally need any readjustment for the life of the instrument. If a puller bar has no play at all, it will not move smoothly, and there's a higher probability that it is dented by being pressed against the upper V-groove bearing. The puller bars are made of high-quality tool steel, and we put a lot of effort into making sure they are perfectly straight. And because of this, the steel that the puller bars are made of cannot be hardened, so the bars are softer than they look. That means, on the other hand, that when trying to eliminate the vertical play, it takes only a very little overshooting to put a dent in the puller bar. And while that dent may not look like much more than a shiny spot, it does not allow the puller bar to run perfectly straight anymore and may completely ruin your pull results. Therefore, do not try to adjust the vertical play of the puller bar unless instructed by Sutter Tech Support. In addition, do not apply a lot of horizontal force to the puller bars to avoid bending them. It pays off to clean your puller bars and V-groove bearings from time to time. Use a cotton swab wetted with ethanol or isopropanol to remove dirt buildup from the V-grooves and their mating surfaces on the puller bars. Do not apply any lubricant to these surfaces or to any of the bearings on your puller.
The pull cables are attached to the ends of the puller bars on each side. They are routed around the upper pulleys and then over a pair of lower pulleys underneath the base plate and on to the pull mechanism. First, let's make sure the pull cables are properly attached. The end of each pull cable is terminated with a crimp-on switch. The majority of the pull force is transmitted to the puller bar by the cable retaining screw. Inspect the cable retaining screw and the switch on both sides. Here's how it's supposed to look. The cable is firmly clamped and the switch is parallel to the puller bar. If there's a little gap between the switch and the hole in the puller bar, that's perfectly okay. If the switch is at an angle in contrast, the retaining screw is loose. Once pull is applied to the cable, the switch rotates outward and sideways force is applied to the puller bar. Contact Sutter Tech Support if your puller looks like this. Now let's take a look at the actual pull cable adjustment. Two aspects are important. First, the pull cables must have a certain amount of play, and second, the play must be the same on both sides. To check for correct play, unlock one of the puller bars from its spring stop and move it to the center like this. Hold it at the finger bar with one hand and tap the pull cable close to the rubber bumper. The cable should have about 2 mm of play. In other words, you should be able to push the cable roughly until it sits on the bottom of the cutout in the bumper. Do not use too much force and make a kink in the cable. Under no circumstances at all must the pull cables be under tension. If you cannot pull the puller bars together until they sit against the head screw in the slotted hole, ouch! Call Sutter Tech Support immediately. If the pull cable is tuned to treble C, or any other note for that matter, it's under tension and it shall not be. The second aspect to check is that the amount of play is the same on both sides. Here are two techniques for this test. Pull the puller bars all the way together. Now tap one puller bar against the hard stop and watch the lower portion of the pull cable on the other side. You should see movement that corresponds to your tapping. Reverse sides and repeat. If you see the movement to about the same extent on both sides, you're good. Another simple test is releasing each of the puller bars while holding the other one at the hard stop. Both puller bars should drift outward by about the same distance. If a pull cable is a little too tight or too loose, it can be adjusted to the correct tension as described in the user manual. We strongly recommend, however, that you check back with our tech support before digging into your toolkit.
Each Sutter horizontal puller has 4 pulleys, one on each end of the upper pulley assembly and 2 lower pulleys concealed underneath the heating element. The pulleys on your instrument may either be silver, as seen on the P-1000 puller here, or black. The pulleys guide the pull cable and route it to the lower pulley assembly. Their smooth operation is crucial for the uniform movement of the puller bars and reproducible pull results. Over time, the small amount of lubricant that is contained in each pulley bearing will age and may eventually freeze up the bearing. Debris particles from the air will team up with the chemical aging of the lubricant to accelerate this process. Sometimes a well-meaning human being who applied some inappropriate lubricant to the bearings may have contributed too. To test the pulleys for proper operation, make sure the puller bars are clipped into their spring stops. In this position, there's about a 1/4 inch of slack between the pulley and the pull cable. Now spin the pulley like this. If it spins for a full revolution or more, you are good. On the filament pullers, drop the front panel and perform the same test with the lower pulleys. If any of the pulleys on your instrument is sticky, that may count for inconsistent pull results. On the P-2000 laser puller, it is not recommended to open the housing. Please contact Sutter Tech Support if you have sticky pulleys or need help with the lower pulleys on your P-2000 puller.
Let me summarize what we learned today. Variability and inconsistency in your pull results can be caused by defects or poor alignment of the puller bars, the pull cables, or the pulleys. This video teaches you how to determine whether each of these 3 components is in good shape. The vertical alignment of the puller bars is critical for the proper operation and reproducibility of your puller. Never attempt to adjust the play of the puller bars without consulting with Sutter Tech Support. You want to clean the puller bars and the V-groove bearings every now and then proactively, and if you observe variability, you definitely want to clean them. The pull cables are designed to have some play, and the play must be equal on both sides. The pulleys must spin freely. If any of them does not, your puller needs attention. And last not least, each of the moving components on your puller is designed to work without regular lubrication. So lubing any of them is more likely to cause damage than to do any good. Keep in mind that variability in the pull results can also be caused by inappropriate program parameters or by issues with the heating element, that is, the alignment of the laser or the heating filament. Sutter Tech Support is there to work with you and determine the root cause of your particular issue. Consider this video a diagnostic tool, but do not attempt any adjustments or repairs without further guidance from us. We are happy to help, and we're there to help. That's it for today. Check out our YouTube channel for the growing collection of Sutter tutorial videos. To contact tech support, go to www.sutter.com or give us a call at +1 415 883 0128.